Okay, let's have a look at the point cloud parameters. The first one is distance clamping. Here, the user set the distance clamping to fill the distance of the LiDAR detected points between min and max. So for instance, in my case, between 0.3 or and max 7 meter. So any point closer or further away from this will be clamped and will be removed from the final point cloud. The second parameter is the reduce the number of points. Here we can use decimation to either get more point or less and less point. This again depends on your flight and the density of the point and the scale of the environment. Next we have noise filtering. Here we have three options: none, which doesn't apply any noise filtering, a statistical, and clustering. These are two different approach and algorithm for removing noise from the point cloud. I'll start with clustering. So when clustering is enabled, you can see a parameter called radius. When clustering is enabled, the filter identifies all connected point groups of points, aka clusters, based on a specific search radius. Points are considered connected if they are within this radius, which we specify here 50 millimeter. While many clusters may be present in the input point cloud, enabling this mode ensure that only largest connected cluster, the one that contain most of the point, is kept in the point cloud. This is particularly useful for removing noise in a small isolated points group. Since random noise usually comes from very small clusters that are automatically discarded with this. So rules for setting the radius. As I said, this parameter controls the neighborhood distance threshold. Points are considered connected if they are within this radius from each other. So a smaller radius will lead to more fragmented clusters, while a larger radius will merge more points into a fewer, bigger cluster. So the choice depends on the density of the point cloud and the scale of the structure you want to extract.